Good afternoon, everybody. Welcome to another episode of Dispatches from the Energy Transition, episode 9. Today, we'll be talking about microgrid communications and controls. As always, Dispatches is brought to you by Mayfield Renewables, Outfit, and much thanks to Solar Builder, a supporting partner of Dispatches. I'm the principal of Outfit. We are a design studio that helps enable project developers, manufacturers, and service providers accelerate the energy transition through visual storytelling. And as always, I'm joined by my colleague in Dispatches and a lot of the work that we do together, Lucas Miller of Mayfield Renewables. How are you, Lucas?
I'm doing well, Robert, getting sunscreen ready for Inner Solar San Diego next week. So ready to get out of the rainy Pacific Northwest and the sunny San Diego for a little bit.
I stay in Bend, but it's been kind of snowy and slushy. What are you excited most about seeing in Inner Solar this year? Anything in particular besides fish tacos?
Definitely fish tacos. That's top three, I'd say. Hopefully a little bit of beach time. We're also hosting, which we'll mention at the end of the webinar, our very first live dispatches. So Monday night, we'll be hosting a happy hour at Bay City Brewing. For anyone on the call that's interested in attending, you can reach out to Robert and myself.
And today, as we kind of segue in, we've got another episode focused on microgrids, and we're going to be talking about controls. So pretty excited about that. Why don't we get to our guests?
Yeah, we're switching things up a little bit this month. So less of a specific project focus and more kind of broad conversation about microgrid design considerations, especially with a focus on communications and controls aspects of microgrid design. We're joined by two experts in that field, so really excited to dig into it with these guys. I'm going to let you guys introduce yourselves. So let's start with you, Michael, our CTO from New Sun Road. If you want to give us a bit of background kind of on your professional journey, how you ended up at New Sun Road and what your role is there.
Sure. Thanks for having us on. So I'm Michael. I'm the CTO. I'm also the Chief Product Officer at New Sun Road, one of the co-founders. My professional journey went through Silicon Valley for many years in a totally different space. Ended up in advertising technology for many years. I got to work with Bill Gates a little bit because the company I was working at was acquired by Microsoft. I was at Microsoft for many years. I ran a big chunk of the advertising platform at Microsoft, not the things that didn't have to do with search, the search bar, the other things, the banner ads and things like that. Did that for a long time, worked a lot in privacy back a long time ago when nobody cared about it, and eventually left Microsoft proper, moved with my family to Tanzania, where that was in 2014, and that's when I got into the solar space. I was working with a different part of Microsoft that was more of a development part, and I started Microsoft's work on affordable access to energy in East Africa. I was also doing various things related to agriculture for smallholder farmers. So I ended up spending a few years living in East Africa. And as I was transitioning back to the US, New Sun Road was just starting on an island in Uganda, working with a fishing village to bring a microgrid into that fishing village that was providing both internet and energy. And Microsoft was just starting to provide funding for that sort of thing. The folks at Microsoft hooked me up with the guys who were just starting New Sun Road. That's when it all started. I got to go to the village, and it was an amazing experience. How excited everybody was about getting this internet and power. That's when it all started. Then I came back to the US, officially joined New Sun Road, and we pivoted the company to be a platform company rather than a microgrid provider. and we started working with other folks who were providing power to communities. So that's where we started. We're a public benefit company, which I guess I'll talk about in a second, but that's when it all started, and I've been with there ever since. I run all of the engineering, technology, product, services, that sort of thing.
Great. Yeah, there's really, it seems, a lot of parallels between your professional background and New Sun Road's kind of company origins, which we'll get into here in just a minute.
Yeah.
But before we do that, I want to turn it to Nate Mills, our other guest today, VP of Operations from American Microgrid Solutions. Nate, in prepping for this, I couldn't help but notice your background, and you have a wide range of degrees and a really interesting story, I think, on kind of your professional background and career upbringing. So you have naval engineering degree, mechanical engineering, planetary sciences. So you tell us a bit about kind of what led you to your role in American Microgrid Solutions.
Sure. So yeah, thanks for the intro. And I do have too many degrees. There's no doubt about that. I was Navy for 21 years before I was at AMS, and the Navy just kept sending me back to school. I guess they decided I wasn't smart enough yet, and you got to go get another degree. So I have been around the academic block a few times. Most of my Navy time was in submarines. All submarines are nuclear powered. So a lot of the experience I bring with me is from operations and then program management for nuclear systems. And that, I think, is, a submarine is in some sense just a mobile microgrid with torpedoes. And that sort of mindset of, hey, this really has to work is the technical part of what I bring to our company. So as the VP of Solutions, part of my job is to make sure that the solutions we're bringing to our clients are actually going to work, which means I have a lot to say about the architecture of the system and the details of the engineering. Because while I am not doing the engineering myself, I know what the drawings are supposed to look like. So that's our role on the technical side. One of the scars of nuclear powers that I don't like unpredictability. So on the technical side, we can manage that, right? On the business side of how a microgrid comes together, there's tons of uncertainty. And so that part is a new area for me. And in this industry, I've found that there's much less standardization and far fewer sort of common expectations than there are for a very large program like the Defense Department. So that's all been very exciting for me. On my way out of the Navy, I was looking for the next thing that I wanted to do. I knew that I wanted it to be at least related to climate change. I knew that I wanted to do something with the next 20 years that made as much of a difference as what the last 20 years have done. And in my networking, on my transition out, I met up with the founder of American Microgrid Solutions and have not looked back since.
Nate, and both New Sun Road and American Microgrid Solutions work with Mayfield Renewables on the engineering and microgrid side. So we're pretty excited to have you here today.
Me too. Thanks.
Yeah, thank you both. And let's dig into it. We do have quite a bit of material to go through today. So we're going to stick with you here, Nate. Let's kind of zoom out a bit first. We're not going to look at any specific projects necessarily, but give us a sense for what American Microgrid Solutions does, who your typical clients are, and what areas you like to work in.
Sure. So we were founded in 2016. Our CEO, Jeff Oxenham, was a utility vice president. And as he was sort of surveying the infrastructure, the landscape of the state of the grid and how it was aging, he realized that the future of power is distributed. He also realized that the utility industry was not doing a great job of keeping up with that. And so he set out to change it on his own. Now, changing the grid is kind of a big thing to bite off, right? So we got to focus somewhere. The way that we focus is by asking the question of how can we do the most good right now, right? And our answer to that is to install resilience in the places that need it most that are unlikely to get it any other way. Those are the types of projects we do. And I say like they need it the most because most of our work is in low-income or rural communities. And these are communities that don't have a lot of other resources internal to the community. They don't have a lot of money, so they can just go somewhere else during a disruption. So they're the ones that need something the most. I say they're unlikely to get it any other way because these tend to be hard projects, right? So the range we're talking about is something like 250 kW combined inverter on the solar and the battery side. So that's about the size that we're in. And that size on its own is not enough to get a small to medium-sized EPC real excited about chasing after these, particularly if you consider that they're often old buildings, there are a lot of stakeholders, they don't have enough money, and they have no time, right? Like if you think of a community center in a low-income community, they have 100 different things going on and services they're trying to provide, and trying to figure out a power system is the last thing on their mind. So our role in bringing resilience is really to help them through it from start to finish, right? Find the client, help them understand what the right answer is for their building and their values and their goals. Find someone to install it, because we are not an EPC. And then once it's installed, we become the operator. So we care from the very beginning all the way to the very end and beyond. And when we bring resilience, yes, it's a power system, right? So today we're going to talk about microgrids, and we're going to focus on the power system part. But a microgrid is not a resilience hub. That on its own does not provide the sort of service to the community that we're really after. So we also build resilience hubs, which take a power system that keeps the lights on and enables other things, right? Those other things are a structure that can withstand the risk that you're trying to protect against, a communications plan, both internal and external, to help people understand what that facility can do for them, an operations plan that makes sure that the people that work the resilience hub know where they're supposed to be and when, right? Who's going to get the water bottles out and where do they go? That kind of stuff. And then programming so that the resilience hub can tell the community in good times and bad what kind of services they offer. So we build microgrids, but we also build resilience hubs and bring those other pieces in. Most of the clients, by the time they come to us, they already know that they want some sort of resilience, right? If you were just going to do an economic project and you were looking to save money, you'd probably do solar only most of the time. So the vast majority of our projects are backup capable batteries, maybe with a conventional generator, maybe not, depends on what the site needs. But those are the projects we're focused on. So that's really small scale, right? That's one building, one set of clients. That project is very important to them, but not very important to the grid. So if we're going to change the grid in this way, we don't want to build a couple of projects. I want to build 1,000 projects. And when you think about that kind of scale, that's why we need some sort of common element across all the OEMs we partner with and all the different solar manufacturers that could possibly be in the system, existing or new. We need something to tie all those together, and we need it to be flexible enough to accommodate multiple architectures. We need it to be scalable so that we really can do 1,000 at once, and we need it to be simple enough that it doesn't break the bank. Because while most of these projects are at least partially grant funded, they do care about cost. It matters every time. So New Sun Road is the partner that we're working with to really bring those attributes together. Something flexible but scalable and simple enough that we can implement it easily across multiple platforms.
We're talking a little bit before we went on air today, and you're speaking to your naval background and standardization. I think American Microgrid has done a really great job of that and your success in the past few years. Where do you think the industry has room to grow in regard to standardization? And then could you just talk a little bit about, from your perspective, where larger, more complex projects, they're more prescriptive? I'm just kind of curious from your vantage point on the ground.
Sure. So I would say the standardization of the components themselves, right? And in terms of sizing and protocols, that sort of thing, that is really more in Michael's wheelhouse, right? I care about the standardization of the application, our ability to get through an interconnection application, our ability to get through permitting. So where I think the industry is headed is, UL 3141, big deal, right? UL 96, trying to get fire suppression systems or fire prevention systems aligned so that everybody is speaking the same language and we don't have so many sort of personal opinions at AHJs or at utilities that interfere with a smooth entry into getting these projects going. So our biggest stumbling block has not been so much the details of what the components bring to the table, because we have a few very stable partners that we understand very well. and we've learned how to integrate New Sun Road with them. So I'm pretty happy on that side. It's very challenging to work through interconnection because it sometimes it seems like it's at the whim of whoever is reviewing your application.
So appreciate that context.
Yeah, and I really liked kind of going through the AMS. Also, I'm going to just refer to you guys as AMS from here on out, Nate.
Yeah,
In reviewing your website, you guys talk about kind of in your mission statement is really helping this transition from the quote unquote old grid to the quote unquote new grid. And you've kind of alluded to that a bit already, but if you could elaborate a bit on what that means to you, I think that's really in line with what we're going for in this dispatches webinar. Is we call it dispatches from the energy transition. So we're referring in part to that transition from old to new grid, but curious to see how you see that transition and how you would maybe define the new grid and old grid.
Sure. So old grid is the one everybody knows, sort of like hub and spoke, in a lot of ways limited by transmission capacity across long distances, and across short distances, which is where we would have the most impact, even limitations on distribution lines, right? How much power is required of that distribution line, what non-wires alternatives are available. And so, in terms of like linking this back to the controls and communication piece, we would like to, everybody I think would like to make virtual power plants simpler, right? That's the goal, is to be able to use all of these assets that are distributed all around the country in a coordinated way with known communication protocols and expectations for performance. But that's really what we want, because then we don't have to build a lot of very large new power plants, right? Whether they be fossil fuel or nuclear or whatever, like we don't have to build a lot of power plants because we have a lot of distributed capacity spread around the grid already. How we use that capacity effectively has always been the question, right? Whether it's, how much can we feed back into the grid and what limitations do the existing substations have? Or how do we dispatch from the batteries to either offset site load or export back to the grid to offset the demand, either at just, peak times or because there's literally not enough capacity in the distribution lines. That's really what we want. And that's another reason that we need 1,000 of these operating, because a few does not make a difference to the grid. 1,000 really does. If you can bring on even 1,000 100 kW batteries, that's a really big deal. So in the old grid, it was all dominated by utility-owned assets, but like way back. In the new grid, we see that as the prosumers, right? Producers and consumers cooperating with the utility, being compensated for the value that they bring. That's the goal.
Nate, we have a live question for you. A big aspect of dispatches is to join the conversation. Everybody that's in here, you're free to send us questions. I'll try to answer as many as we can through the episode. Ken Hoffman from ESS here in Oregon has a great question. And I would like to also open up this to Michael and Lucas and perhaps myself as well. What do you feel is the main thing hindering the scaling you seek? Thousands of microgrids.
I really do think it is standardization of requirements for what it takes to install one, right? You've probably heard of Electrify America and like that effort. Like in Australia, the only way you can install solar for $1 a watt is because everybody knows what the requirements are. The permitting and interconnection applications are very streamlined, and everybody knows the rules. And if you know the rules, it's easy to comply because all the manufacturers will fall in line. We'll know exactly what to do, and we can just build it and then build the next one. And we don't have to wonder what the utility is going to say. So I do think that the number one thing in our way is being able to know before you even start whether or not the project will be possible in the way that we've drawn it.
Do you share perspective, Michael?
Actually, I would just double down on what Nate's saying. I think that's pretty much the number one thing. I don't think there are technical hindrances. It seems much more just regulatory, really.
Okay, and I see one other one from Craig McBurney in the chat here too. So VPP not a pipe dream, right? It is an unrealized dream, but pipe dream means that's never going to happen. We have several aggregation partners that are already implementing VPPs, and I don't think the utility, at least from their perspective, the utilities aren't really blocking them. It's more a matter of, is the compensation the utility is willing to provide for a VPP service make it worth entering on the business side, right? I think that most utilities want relief, and the more targeted that relief can be, the better, right? You don't have to have a statewide incentive. If you just have one neighborhood that has constrained distribution lines, all the better, right? Dispatch your VPP in that area, and you don't have to pay as many people as much. So I think those are on their way, and maybe not as far away as we think.
I might be able to.
I just want to say real quick, VPP will be a spring episode of Dispatches with Adam Boucher from Molecule Systems. So that's coming up. Go ahead, Michael.
I was going to say, I could say something about Drew's first question, about EVs as microgrid for the masses. We do see some progress there. So that first of all depends on chargers being bidirectional. And so we do see some advancement in that direction. And then the EVs need to be able to communicate with the bidirectional chargers, and that requires some updates to the communication protocol between the EVs themselves and the chargers. And we see progress in that direction. And we have some projects ourselves with EV charger manufacturers who also have relationships with other folks like school buses and cars, and so that's definitely progressing. I would say it's progressing. It's not there yet, obviously, but it's progressing.
Yeah, and Mayfield has looked into kind of bidirectional EV charging a bit over the past year or so, and we have struggled to find many bidirectional options out there. It seems that there's two regulatory environments here that didn't talk to each other before, being automotive and utility, and now they have to. And so it's a lot of finding middle ground and who's in charge of what, communications protocols alignment. So it's a complicated problem, but when we get to a solution, which should happen in the next year or two, I think, yeah, that's just another huge resource that gets added to the grid. I do want to switch us over.
Yeah.
Michael, let's shift gears just a little bit here. So turning from AMS, now let's look at New Sun Road. If you can give us kind of an elevator pitch, origin story, what you guys are focused on and what your typical projects look like.
Yeah, sure. So as I mentioned earlier, the New Sun Road's first project was a fishing village on an island in Lake Victoria in Uganda. So that was back in 2000. The company was started in 2014, and that project was in the 15-16 started. We're a public benefit company. Corporation. I can talk a bit more about that later if you want. But our mission has always been to accelerate the adoption, deployment of renewable energy, and we have a particular focus on access to remote communities. We've, over our history, have worked on both, so primarily the energy side of things, but also the connectivity, the internet connectivity. So we started our work in Africa, sub-Saharan Africa, working with organizations, companies that, like mini utilities, that were providing power to rural communities that were completely disconnected from the grid. From that, we, as an evolution of the company, have been doing a lot of work in South America, Latin America, Central South America. A lot of that is telecom. So we have, like, it says 1,500 there. That's, every day. There's many more. So I'm not sure what that number really is, but somewhere between 1,500 and 2,000, several, 20 plus countries. And the majority of those systems that we have out there are these towers, telecom towers, which you can, no, none of these pictures are a telecom tower, but just that they're at the a lot of them are at the top of a mountain somewhere. Imagine like this green lush mountain in Honduras that the only way to get there is 2 days on a car and half a day on the back of a donkey to get up to the top of the mountain. And you know, some of our folks have been out that way to help with deployments. And I say that because from the early stages of the company, there was, you know, we cut our teeth on these requirements of dealing with poor connectivity or intermittent connectivity, high cost to serve. So there's this really, you know, the importance of having reliable telemetry, reliable remote control, the ability to get as much information about to know that something's going wrong or not, and then to know if you're going to have to send somebody out, what you need to do for when that person does make that journey out to the site to fix it. So that's always been a high priority for us. All of our whole platform, from the hardware all the way through to the cloud, is designed with these constraints in mind. And that ended up, you know, so I was talking about Sub-Saharan Africa, Latin America, telecom, and we have a lot of systems in North America as well. We work with Pacific Gas and Electric. So the top right-hand picture is a Pacific Gas and Electric site in California. PG&E has a wildfire mitigation program where they put in standalone power systems. So they take the power line down, because, as we know, power lines are one of the big causes of wildfires. The wind blows, there's a spark, and then you get fires. So they are taking down power lines, and they can either put them underground or they can just get rid of them completely. And oftentimes the economical choice is to get rid of them completely and put a standalone power system on the other end and service the off-takers there. Whenever PG&E does that, we're the platform of record for that program. We also work with Southern California Edison and other utilities in the same way. And but you know, these are, again, remote, and you have issues of connectivity, and there's nobody there managing the power system. You need to be able to manage it remotely. So that's really like our focus as a company, and our target customer. You know, we're definitely B2B. We're not B2C. We're not really meant to be a residential system, although we have a lot of residential and mostly high-end residential end customers, but that's not our direct customer. Our direct customer is somebody who either owns and or operates and maintains a fleet of systems that they care about. They want to see, they want to keep track of many systems, and importantly, those power systems might have a very heterogeneous equipment base. You know, there could be Schneider in one place, Solarc in another place, SMA somewhere else, or Dynapower, like all the different inverters and batteries. And what our platform does is normalize all of that for them so they can manage their fleet. We also, I guess, mentioned that we do have a program where we put in internet and power into, that's the lower right-hand picture there, where we work with communities in Guatemala, the government of Guatemala, USAID, such that it was, and the Gates Foundation, USTDA, to put in these power systems and connectivity in communities, working with NGOs to do digital literacy training focused on women and girls. So that's an amazing project. And if anybody would like to help us with that project, there's a way to help us, especially now with things going on with the USAID. I'll put a little plug in for that.
A couple quick questions, because we have a lot of technical detail to get into shortly. Brief overview on what a public benefit corporation is.
Oh, yeah.
And I'm personally curious as to the business model shift and what precipitated that for New Sunroad.
Oh, yeah. So, I mean, simply the PBC means that we have a mission. We're mission based, and so the the responsibility of the leadership of the company is sort of dual. We have our mission and we have our fiduciary responsibilities, and we can make choices that are aligned with our mission, even if it isn't the most profit maximizing choice. And like maybe one example of that is that given the cuts to the program, the USAID program in Guatemala, we have to make a decision about what are we going to do, and are we going to supplement there, how are we going to deal with that? And our ability to make that kind of decision is really grounded in us being a PBC. The company, the mission's always really stayed the same. Serendipitously during COVID, we got a lot of pull to work in North America. So that's really, like, the company has evolved really by pull. So we work with battery manufacturers, and it's really, our growth has been kind of word of mouth and partners to partners. So we work with somebody, they say, oh, we want to work with this equipment. And then we meet the equipment manufacturer and they say, oh, that's super cool. We have these other customers who need what you do. And that's really how our growth has been.
The aspect of the energy transition is integration between hardware and software, particularly related to complex systems. So a final question to you. Do you make hardware, software, or both?
Yes, I guess I'll touch on that in a couple slides, but we definitely make hardware. We make a controller, it's like this big, but we don't make inverters and batteries.
Move into the meat here.
And the majority of what we do is in the cloud.
Sure. Well, I think we're going to dive a bit more into kind of technical specs, system level considerations here for a bit. So what we've got on screen is a very simplified kind of single line-esque diagram demonstrating what one microgrid could look like. You'll notice we've got Stellar Edge in the upper right corner. That is the New Sun Road controller. Dashed lines being communication lines from the controller to various components within the system. Hard lines being power lines between each of those devices. I'll turn it to you here, Nate. As our resident microgrid expert, if you kind of walk us through what we're looking at, what some of these typical load groups, sources, loads, generation sources, et cetera, are in these systems, and how they're all talking to each other.
Sure. And I would classify this as like a sample system, sort of representative of some subset of microgrids, because the relative orientation and sizing of all of these components can change in any given system. So we've got here utilities coming in at the top. This particular building has a generator with an ATS that is on the utility side of the main service breaker. And then down in the main distribution panel, you've got a series of sub-panels that are fed off there. They may or may not have transformers associated with them. And that's what exists when we show up. So the blue boxes, aside from the generator, are what we bring when we bring a microgrid to life. So we will add some solar. That's the PV bottom right. That's the ESS. So we'll bring the battery as well. And we'll bring a control system. That's the Stellar Edge. And then some version of load shedding often. And that's what these contactors are intended to show. Except for one, and that's the utility contactor at the top of the main distribution panel. So in normal operation, I'll keep this short because I think you know how these work, right? The point of the system is to maximize the economic benefit of the assets that you have. So the job of the Stellar Edge is to keep track of what's happening as far as loads in the building, understand what the rate schedule looks like, and dispatch the battery and or solar as needed to maximize the economic returns. When the power goes out, it gets a lot more interesting, and that's why microgrids are cool. As soon as the power goes out, the utility contactor will open, right? We have components that do that. That's typically not the Stellar Edge. That's typically something else, like an SEL 751 that the utility has experience with and they believe in and everybody is comfortable with. So the utility contactor will open automatically. When the battery recognizes that the utility contactor has successfully opened, it will switch from following the signals from the grid to forming its own grid by controlling voltage and frequency. That transition time, depending on the OEM of the battery itself, can take milliseconds, or it could take 10 to 15 seconds, just depending on what size range you're working in and who the manufacturer is. That transition from grid following to grid forming is also not necessarily controlled by the stellar edge. And so the point I'm trying to make here is that when we talk microgrid controls, there are multiple levels of control systems all throughout the system. The battery alone will have the BMS on the battery modules themselves. The inverter will probably have some kind of native EMS associated with it. And the stellar edge is really a site controller, right? Coordinating multiple assets across the system and optimizing their performance. So when the grid goes down, we've got the solar that's providing power to the main bus and then to the loads. Some of those loads may or may not be shed, just depending on what we decide to do with the system. The battery is in grid forming, but if the production from solar can't match what the loads are requiring, the battery will drain down, and when it gets to a sufficiently low state of charge, the stellar edge will send a signal to the generator to start. The generator will start. The contactor at the utility contactor there will see that there's stable power on the utility side of it. It doesn't really care where that power is coming from. And then we can sync across that contactor, close it, and allow the battery to charge. During that time, you could be in grid forming or grid following, depending on the OEM. Again, we'll charge the battery up, turn the generator off. The utility contactor will see that as a loss of power and open just like normal, and the battery will be back in grid forming. And we do that dance continuously until the power comes back. So that's how this system will work. And the stellar edge is most active when we are on grid. When we are off grid, it's making decisions about what loads can be supported based on the state of charge of the battery, how much solar is coming in, how much sun we're expected to have later in the day, the level of fuel remaining in the generator, all those sorts of things, right? So there's a lot for it to do after we make the transition to off grid, but it is not trying to power balance, right? That's the battery inverter's job. The battery inverter will be load following. It'll automatically, instantaneously respond to changes in load. That's not the stellar edge's job, and the control cycle is too long to enable that to happen. Okay, so that's how this system would work, going on and off grid. If we zoom out a little bit, like rewind to how did we even come up with this architecture in the first place? The place that we start when we are meeting with a client and doing our design meetings and trying to figure out what the right system for them is to really figure out what you're trying to do, right? Which loads do you intend to support? Because some of these might be HVAC loads, which may or may not be important for that site. Some of them may be EV chargers, which we would almost certainly cut out during an outage. And some of them may be critical loads, in which case we wouldn't even cut them out. And that's like the one on the far left where we don't even put a load shedding contactor on it because we always want that to be powered.
Nate, I have a question from Austin Early from Baker Electric. I think this is an interesting one. How is this achieved? When operating isolated from the grid, microgrid operations, failure of communications between the paralleling device and microgrid control systems shall result in generating facility smart inverters to cease to energize or trip within 2 seconds of loss of communications. Does anyone want to take a stab at that on the panel?
Okay, that is in quotes. And so I am assuming that was pulled from a reference somewhere. But there are many references. So I guess we put it this way. If we're off grid, and so this is operating like any off grid system, there will be some requirement for how the system responds to faults, right? Maybe the battery loses its communication with the utility contactor, right? That's an easy one, right? The line breaks somehow or becomes disconnected. Then the battery does not know what state the utility contactor is in, which means that it's not safe to operate it in grid forming mode. So it'll fall back to grid following mode. If when it does that, it does not see an active grid signal, then it will trip, right? It'll shut down. And so these microgrids are typically fail safe and by that I mean like not feeding power to some unknown condition. So it does depend on having, you know, consistent communications with the various components of the microgrid. And I think like what he may be pointing out is that rightly, like the more of these connections you have, the more potential failures you have. So the more complex the wiring, the more complex the communication, the more chances there are for something to go wrong and for the system to trip offline. One of the things that we build into our systems is some amount of manual backups. You know, so for example, if you have a load shedding contactor and you lose communication with the load shedding contactor, or you lose relay power to the load shedding contactor, and it's a normally open contactor like most are, then we, you know, if it's a critical or somewhat critical load, an essential load, then we want to bypass that contactor. We want to have a way to do that. And the key is to anticipate that need as much as you can and build that in. What we don't have is, you know, completely redundant communication paths between all the things that might need it, right? That gets out of hand in both cost and complexity pretty fast.
Nate, I want to ask one more question, then we can dive a bit more into Stellar Edge and kind of the specific features and functions of the controller. In prep for this, we talked a lot about kind of through the development process, there are a lot of trade-offs that the end user might have to consider. One example being load group prioritization. And we got a question from Frank Lorch. Do the load groups here have backup or critical load panels? Are they connected as a whole home backup? So maybe not specifically for this example, but in general, how do you approach that conversation with the end user on, you're going to have to prioritize loads. Maybe we can't back up everything. We need to develop a load schedule together. That's something that Mayfield often does for feasibility studies, but I'm curious on your end how you guys approach that problem.
Yeah, same, right? Like we have to find out from the client what they really need, because it may be, you know, we need the dental suite for sure, and also the elevator, and then, oh yeah, if we don't keep the IT system up, we can't retrieve anybody's records. So we need those three things. And then part of our job is to go find where those are in the building electrically and make sure that they're all brought together in a way that we can support them all, right? So either that means rewiring some components to a critical loads panel that's designated for that purpose, or supporting multiple panels. So sometimes it's easier to just take the whole panel if you're going to have to support half of it anyway. So that discussion for sure we have to have, and it's really like that's the beginning of the trade-off discussion, because if you want to support the whole building for a long time, I'll just tell you right now, it's too expensive, right? Not even knowing anything about the building, it's probably going to be too expensive. So what do you really need? How long do you really need to go? And the trade-off between endurance and cost and how many loads you want to support is a conversation we have to have every time. And endurance is not even one number, right? It may be, well, we need to support these loads indefinitely. Maybe that's really the answer. And if so, that means we need to have a high solar to load ratio for those loads, but that doesn't mean that those are the only loads that are ever supported. If it's a sunny day and the battery is full, we can bring on more loads, and we want to sequence the degradation and return of those loads according to priority. So that's what we talk about, right? And that trade-off is always there. Like, how long can you go for so much?
Or in short, Nate, it's where do we mitigate risk to align opportunity? It's like almost all of these projects have that question, right?
Yeah, absolutely. And then the other trade-off that we have to consider is, you know, we've been talking about resilience and what the microgrid can do when off-grid, but what about when it's on-grid? Like how you're actually using it has a direct relationship to how much battery you have in reserve if an outage happens at the exact wrong time. So do you prioritize short-term resilience, in which case you really want to be able to get through 2 hours anytime, right? So that means we have a certain amount of reserve capacity. It's not available for economics, so your returns are somewhat less. Or you say, use the battery for economics, just do what you need to do, squeeze the most out of it. What we care about is the upside of long-term resilience. We want to manage an outage that lasts 2 weeks, which is the standard in Oregon. So if you want to manage an outage that lasts 2 weeks, then you oversize PV relative to the loads you intend to support and make sure that they're enough to consistently refill the battery so it can last through the night and get to the next day. Right? That's the goal. So those are all trade-offs. And the last one I would mention is just sort of this idea of flexibility versus the complexity that we're trying to build in. Like, we want to be flexible. We don't necessarily even want to make all the decisions right now and just hardwire each one of these load shedding contactors to the main utility contactor. We could do that. It might be cheaper, but it really removes any kind of smart decision making that you want to do in the future. Right? You may have different types of loads that come on. You may restructure the building a little bit, and you may have a change of leadership, and it's as simple as that. And they say, no, we want to use it this way. So having the Stellar Edge, sort of bring together that flexibility without making it overly complex. It's like using simple components to do complicated things. That's the paradigm that we want to operate in.
Yeah, and you gave a few great examples there, Nate, one of which we'll actually walk through here with Michael in just a minute. But I want to quickly give you a minute or two here, Michael, to walk us through another diagram. So very similar to what we were just looking at, but kind of really focused on the controller in this one. So if I'll open it up to you here, Michael, if you can kind of walk us through, there's many different inputs to the controller. What could those be in addition to PV, energy storage? Looks like generator capability here, perhaps wind as well. And then what is the controller doing for the system?
Yeah, great. So first of all, I'll zoom out. The controller is, we call it the edge, and it's really, the edge of the whole platform. So the platform is the controller, and the what we call the Stellar Microgrid OS in the cloud. Yeah, as you said, and is in the prior diagram, the edge often talks to many different things. It'll talk to the PV more than is outlined in that prior slide. I mean, to talk to anything, sensors, and any smart equipment. And then the controller is managing the microgrid in the way that Nate was describing, and also serving as a gateway to send the data up to the cloud and to our platform in the cloud, where you can see everything that's going on. You can send commands from the cloud, or you can send commands from the controller. The controller hosts also a portal from itself, and once you're in the cloud, you've got access to all cloud computing. There's AI you can do, and lots of analytics, and there's a lot of that in the platform.
And I'd like to maybe jump us forward. I know we've got about 10 minutes left here. We do have some kind of peeks inside the platform here. So I'll hand it off again to you, Michael, to kind of walk us through. I know we have a couple slides here, and then a few more with one specific function example.
Yeah, and just so, when should I be done talking?
Probably with 5 minutes left, 3 to 5 minutes, I guess.
Okay. So that's fine. We'll do that. So we're just going to show a couple images of the platform. There's much more in the platform than what you'll see. Obviously, this is part of what it looks like when you're looking at the details of a specific system within your fleet. You can see the power flow diagram in the bottom left there. That will adjust depending on, there are all sorts of different system topologies that can show up, and that diagram will look different depending on the topology. So this one has DC coupled solar in the top right, and the battery on the bottom, the top left and the bottom left. It's got a generator that connects to an ATS on the sort of middle right. The heart of it is the inverter, the battery inverter. It's got a grid connection, and in this case, this is an example of a grid that's a utility run grid that's feeding a distribution system. So there's a PCC, the point of common coupling, where this plant, as a microgrid as a plant, is providing power to various off takers. So you have site loads, the sort of parasitic loads, HVAC, and the things. That's what's on the bottom right. There are charts on the right, and there's a whole like carousel of charts you can go through that show you what's going on. There we have some standard ones, and they're configurable. We work with our customers to get to adjust what's shown here to reflect their business, and then what you don't see is there's various controls that you have access to. And maybe the one thing I'll call out is that we see the platform as a hub. You might be working with equipment that itself has its own portals, and so we don't try and reproduce everything in our platform, and we'll give you links to other platforms. Like here, there's a link to Schneider, but it could be anything else, SMA, or anything else that has a platform, and we'll deep link you into that other platform as deeply as possible. So you can go to the next slide. Here's another view of we have that prior view was really like what's going on right now in the moment today. How's it done? We have more performance analytics views as well. Like here's just one example of energy over some time. And there's several charts that just describe what's going on. Just if you look at the pie chart, it's saying 97.5 of the power of the energy that was produced was renewable solar, and then there was 2.5% generator. And here you can see how much came from the sun, generator went into the battery, out of the battery to the load, and then the sort of parasitic loads there on the bottom right. And that's just an example. There are many others. Go to the
Michael, how useful is it for your customers or people that you're working with to see all this information? So it looks like it's laid out pretty neatly.
Yeah, it's super useful. We get a lot of positive feedback. I mean, people love it's maybe a better question for Nate, but people love this. And as I say, there's like two, on the first screen, and maybe this one too. So this is a fleet view. You can see several systems at once. We have customers who have a network operating center, a NOC, and they've got a big screen up, and they're looking at a whole bunch of systems and what's happening. And if there are problems, you can see sort of yellow, green, that's really a red normally, and indicating if there's how severe an event is. We can show the list of events. So people use this to run their business, so this is core to their business. And as I said earlier on, I mean, so it's one thing, what's happening? Is there something? Okay, let me deal with it. Can I deal with it from the platform? If not, okay, I need to send somebody out. We actually have within our platform as well, we have a task management, incident management component. And then we try and provide as much information as possible to have them be ready to be efficient when they actually go out to site. You can go on unless, Robert, you have another.
Yeah, I think let's spend the next few minutes walking through the example we have here, Michael, and then if we can wrap up with a couple questions, we will.
Yeah, so this is just an example. I'll run through. This is a site. The white line, these are all images from the platform. The white line is the load, and the green, the yellow is solar. So this is a typical day. And click a bit. So then click one. So the customer wants to manage this power system with certain controls, and you click. We'll just look at two particular things. They want to keep the battery at 95% as much as possible, because for resilience, like Nate was talking about, but also they want to mitigate demand charges. So they want to limit the amount of import that they're taking from the grid to 80. And when we talk about trade-offs, this is an important question. Like, well, I want to limit how much I'm taking from the grid, but I'm limited by how much battery I have. We'll talk about that in a second. So keep these two numbers in mind. They have a target of 80 and a target state of charge of 95. Okay, so click one. So we can see, obviously their load exceeds 80 at some point. So we need to carve up the top of that load and deal with it. So now let's look at, go one more, and we'll see how the load is being serviced by a combination of the battery, solar, and grid. So you can see how that, you can see the battery is discharging in the morning and then charging in the afternoon. So click one and we'll see, we'll peel away the battery and the solar, and we see this is just the remaining, the grid. And you can see how the edge and the New Sun Road system is maintaining the grid consumption below that target of 80 for most of the day. And okay, so that's go one, and we can look at, go one more, and we can see what does this look like at different times of the day. So let's say click one in the morning. We can see here's the moment where it's discharging. If you look at that flow diagram, you can see that there's power flowing out of the battery on the bottom left. And the battery's already down at 50. That green line on the chart below the one we had been looking at before is the battery SOC. So you see that the battery's been discharging, the state of charge goes down, and then later in the afternoon, you can click one. So about 1:30, the load is low enough that the controller is saying, okay, now I can start recharging the battery, still maintaining the grid below that 80 target, but now using the grid to recharge the battery, getting it back up. You can click one to 95, and you can see so you can see on the green line, but also in the bottom left-hand block of the diagram, that says the battery is now at 95, so it's not consuming from the grid anymore. It's just allowing the grid to meet the load. So that's just an example of a day of controls.
Thanks for that walkthrough. It's great. Very useful to see it live.
And it looks like we've got just a minute or two left. We always close out with just some kind of key takeaways, condensing what we've talked about here today. But first off, defining performance goals is a conversation about trade-offs. We've discussed quite a few trade-offs that are going to be a part of that conversation in any development process. Also establishing internal and external communications functions. I don't know if we spent a lot of time looking at this one today, so I might open it up if Nate or Michael, if you guys have a quick 30-second response on this one.
Sure. Yeah, I'll take that one, Mike. The internal communications, what we mean by that is how the components talk to each other. So for the first time integration between a Stellar Edge and any given OEM, there are a lot of questions, right? What language do they speak? Where does the edge physically sit within the system? How is it connected, and what's, how does the LAN come together where they all talk to each other? And all those things have to be decided. And because the EPC should not be the one figuring this out, they all have to be decided at the engineering level and laid out exactly where they're supposed to go. For external communications, that's a question with the facility, and can we connect to your Ethernet? Or do we have to get our own cell modem? What kind of Wi-Fi network do we have in this area? Those things can be real trip hazards towards the end of the project.
Great, thanks, Nate. Third and final one here. This is almost more personal to this group. We at Mayfield work pretty closely with AMS. We certainly spec New Sun Road on many projects. So as always, a big part of standardization is having good partnerships and processes and working with people that you trust and doing things more than once. We're at time. We've got contact information up here. I know we didn't get to answer every question. If anyone does want to submit anything else to Michael and Nate, you can find their emails here. Again, really want to thank you guys for your time, your expertise, and answering so many questions. We really have quite a few here, so encourage everyone to reach out by email if we didn't get to yours.
We tried to answer as many as we could. This was the most for any episode. And we're going to be live in San Diego, right, Lucas? So on Monday night, we'll have our very first live dispatches at Bay City Brewing. A couple of good friends and colleagues, Brian Wagner, President and GM of CPS America, and Casey Miller, CEO of Alexity, have a very interesting topic around trying to have cost beneficial projects given new net metering 3.0 rules and how that can be achieved through energy storage and controls. So continuing to focus on distributed generation, EduGrid, microgrid topics. We're almost at capacity, so if anybody else wants to attend, you should probably RSVP before the end of the week. Thanks everybody for the episode. Michael, Nate, Lucas, anything else?
Thanks for having me.
Good. Thanks, guys.
Thanks, everyone.